Hello again, everyone. So today we are going to continue with the trigonometric ratios in different quadrants, and I'm just going to do an overview of the four quadrants with the trig ratios in each one. Okay, we're going to start with quadrant 1. So this is Q1 right here, and let's start with the terminal arm. We have the initial arm there. That's our theta. Now notice that in quadrant 1 we have positive x value, so that is positive x, and we have positive y, so this is our y value here, positive y. So it turns out that every single ratio in here, sine, cosine ratio, and tangent ratio, they're all positive. And by the way, let's call the hypotenuse r, or the radius of the circle, and we can go ahead and write all the ratios, and they're all positive values. Okay, that's simple as that. Let's go ahead and do that. Okay, when you write all the ratios for quadrant 1, you get positive y over r for sine, and then cosine will be x over r, and then tangent will be y over x. Notice that they're all positive ratios. Let's go to quadrant 2. The standard position angle is theta, and based on that we are going to use the again go through the sine and cosine and tangent and write the ratios for each one, but this time in quadrant 2. Remember, we are using the reference angle to the standard position angle to actually get a value for that theta based on the quadrant. So let's go ahead and do that. All right, so these are the ratios. Now notice that couple of things. Number one is that some ratios like cosine, they're both positive in quadrant 1 and quadrant 2. Notice that the standard position angle quadrant 1 and the standard position quadrant 2, which is more than 90 degrees, less than 180 degrees, it's giving you the same ratio. They're the same, but it's actually two different angles. So that's very important to know. But other ones, cosine and tangent, they're giving you different values. One is positive, the other one negative, based on the ratios. And you can see, you can pair them up just like that for all other quadrants, quadrant 3 and quadrant 4, and you will notice that a given ratio can give to two different roots or angles depending on if it's positive or negative, and depending on what quadrant it lands. All right, so let's go ahead and go to quadrant 3 and work the ratios in quadrant 3 and 4. Actually, just before moving on to the other quadrants, I want to give an actual example. So for quadrant 1, let's suppose that theta is 30 degrees. I want to show you that sine of theta at 30 degrees, if you punch in a calculator, you get 0.5. And then you do the same thing with the sine of 150 degrees. That is in quadrant 2. So this is in quadrant 1, 30 degrees in quadrant 1, 150 degrees in quadrant 2. You can see that. But that's also giving you 0.5. So that means that if you have a ratio of 0.5 for sine, that would give rise to two different possible angles for that same ratio. And that is true for almost all of these quadrants, all of these angles. Okay, I just want to make sure that you see that as an actual tangible example. So now we have quadrant 3. So this is quadrant 3 now. Q3. Down at the bottom. Okay, so write up the ratios for all of them. Again, the standard position angle is theta. We are using the reference angle to the standard position angle theta to write the ratios, and the way we do that, we are using the actual coordinates. That's why we can actually use the standard position. And now this time, notice that cosine and tangent tangent and sine, they're all negative. Okay, and that's based on, actually, tangent is positive because it's opposite over hypotenuse. That will give us y over x. So tangent is positive in quadrant 3. But here is the thing. Notice that cosine in quadrant 2, right here, Let's go to quadrant 2. Right here, that's quadrant 2. Okay, actually, let me use a different color if I can. Whoa. All right, so different color. So cosine in quadrant 2 and quadrant 3 is negative. They're same ratio, minus x over r, and say minus x over r. You see that? There's exactly the same. All right, so we're going to go do the same thing in quadrant 4 now and see what's happening with that. We're going to write the ratios for all, and then we're going to basically do a summary in all of them. All right, let's do that. All right, in quadrant 4, we are in quadrant 4 now. We have, so quadrant 4, we have these ratios based on that triangle that we have. Notice again, now this time, here's the catch. This time we have, that doesn't look right, but quadrant 4 tangent, if you can see it, is equal to the same as in quadrant 2. You see that? They're exactly the same ratios. So it's very crucial. Why do we need this? We need this because for any given ratio, you could have two possible angles on the standard position angles on a different quadrant. Okay? That is the crucial part of the whole thing that we just did. All right, let's put them all together. Okay, so here it is. Let's start with quadrant 1. Notice that sine, cosine, and tangent, they're all positive. So let's go back up to the first thing that we did. It's right here. All of them are positive. So I just put in there cosine, sine, tangent. That means positive. This is the positive sign plus sine, and it's all positive. Now we're going to go ahead and use that, what we've done above, to fill in the quadrant 2, quadrant 3, quadrant 4 in terms of what is positive, what is negative, in terms of the ratios. And you'll notice that in quadrant 2, sine is only positive. Okay? Tangent, maybe not, but we can go through and check it out. Quadrant 2, where is quadrant 2? Right here. Quadrant 2, tangent is negative. Sorry, we are right, yeah, quadrant 2. Tangent is negative and cosine is negative as well. So let's go back. So that's the only one that is positive. All right. Now in quadrant 3, what are the positive values? In quadrant 3, tangent is positive only. And in quadrant 4, everything is negative except cosine. Okay, so here is cosine. That is the only one that is positive. So the way we remember this, we remember this as this acronym CAST, and it starts in the 4th quadrant, and that represents all the ratios that are positive in different quadrants. Okay, in different quadrants, and in different quadrants are in quadrant 1 to 4. Okay, so that's what that is, and that's basically it.